To learn more about how semantic chunking works, let's go over our notebook, the third notebook, the semantic chunking. We will load a complex dataset, very similar to the one that we had in our example. Then we're going to apply the statistical chunker on some of the documents. Then we're going to add the metadata to the chunks, which is best practice in a RAG application. Here there are some visual improvements, so we can see the output a bit more easily, and we will ignore warnings in our notebook. So there is a dataset that we are loading. It's coming from the Hugging Face hub. It's archive documents, many papers on AI, machine learning, LLMs, which, as you can see in the presentation before, they are quite complex and hard to index. When we repeat the dataset, you can see that we have a few columns. Mostly we'll use the title and the content. The rest are less relevant. These are where we have the text for our encoding. If we print out one of the documents, this is exactly the documents that we saw before, the Mamba paper, the first 500 characters, we can see the title, the authors, the beginning of the abstract, and so on. So let's now apply the statistical chunker on it. The statistical chunker is based on encoding that we do for the sentences. It calculates the encoding of each one of the sentences, and whenever it finds some kind of a difference between the sentences, it will create a breakpoint and start a new chunk. So here we have an encoder. We will use the OpenAI encoder. Remember that this part, the chunking, is done as a pre-process. It's not going to add any latency to the retrieval part. So we can here decide which kind of encoder we want to use for that, the best for our use case. Here we're going to use this remote one, but we can use any other encoding that meets our requirements. So when we are creating the semantic chunker, we pass it a few parameters. One of them is the encoder, the one that we just defined above, but also some limits. What is the minimal number of tokens that we want in the chunk? What is the maximum number that we want in the chunk? Remember that we have a limit on the encoding part. Here we're going to ask it to help us with some nice plots and statistics to understand better how it works. And then let's run it on the documents in index 0 on our dataset. We are not going to have those plots and statistics when we go over all the dataset, but for the couple of examples that we're going to have here to get some better understanding, we will have them. So here is the plot. Let's jump to the statistics to understand what we see here. So overall, this one document was split into 450 sub-documents or sentences. Out of those 400 sentences, it created 46 chunks. About 40 of them were based on the threshold, the semantic threshold. 5 were based on the maximum size. So if we start here, we can see that the first sentences had higher score until we get to a breakpoint where the sentence is very different than the previous sentence. So this is a threshold that whenever we go under it, we create a chunk. There are also a few chunks that were not split based on the threshold because we also have the limit of number of tokens. Those are those 490, 494, and so on. Most of the chunks were based on the statistical threshold. So if we print out those chunks, we can see that we have some characters at the beginning, but each one of those are the sentences. And it decides if to break or not before the sentence. So here the breakpoint was here. The difference between this sentence and that sentence was below. The similarity score was 0.27, which is below the threshold, and therefore it decided to create a chunk. It continues here. So just before we get to figure 1, we decide to break, and so on. So each one of those chunks is a set of sentences that are similar semantically, and the breakpoint are where this similarity goes below the threshold. So let's do it for another document. So document index 1, quite the same. Let's see the statistics before. So now we have 511 sentences, 55 chunks. You can see that here only 41 of those 55 were based on threshold, 13 were based on size. We can guess that this document is a bit more current, the sentences are semantically more similar, but still we have enough breaking point to create our chunks. So here The abstract point is a good place to start. The introduction is a good place to break. So it looks quite similar to what we might have if we had the ability to find the headers in the documents. But here, as you can see, it's based on the actual semantic difference between this sentence and that sentence. And so now let's go and build the actual chunks. It's not enough that we have the breaking point. We want to add some context to the chunk. So what we do here is we add the title to each one of the chunks. So this is the text of the chunk, but we prepend the title of the document. It's a simple way to make sure that we have some context in the chunk. Later on, we're going to see a method which is a bit better to add the context to the chunks. But this is a simplified way to do that, and I hope it makes sense. The next part is to add not just the text, but also some metadata to the chunk. As I mentioned before, this is best practice when you're building a RAG system. You want to have some metadata that you can use to filter. You can filter by the publishing year, you can filter by categories, university, whatever is a meaningful filter to the documents. So here we're going to first add the title. We also append it to the chunks, but we can also have it as a separate field. And we are adding pointers to the previous chunk and the next chunk. This is will give us later on, after the retrieval, the option in the augmentation part, before we sending to the generation part, to add chunks to the chunks that we retrieved. So we can decide to add what makes sense to the generation. If the chunk is too limited, we can also bring the environment of chunks around it. So this is the final output. We have the ID, we have the title, of course, the content with the appended title. Remember, this is the part that will be encoded. So this is the vector that will be used for the semantic similarity, but also the link. So this one has no link because it's the first one, but so we have the link to the second chunk, and from the second chunk we have the link to the first chunk, and so on. So now we have the metadata, and we can take this metadata and the content and upload it into our vector database. We're not going to do that here because the focus of this notebook is on the chunking, but I hope it gave you the understanding how can you apply the semantic chunking, how to enrich the context of the chunk, the text of the chunk, and how to create a simple metadata that will allow you later on, after the retrieval, to get the parts of the documents that make sense for the generation.